Perfect. Thank you, Walid, for giving us the opportunity to present here. I'm Tom Homan from Prominent Fluid Controls. We're a global company, equipment manufacturer for chemical dosing and water treatment equipment. And where some of my co-presenters have focused mainly on RO pre-treatment, I'm gonna take it a step back and look at a little bit of a wider strategies for incoming water disinfection. This can be incoming water into a lot of different processes or different usages. And when rethinking water disinfection, because there's always a need for improvement, there's quite a few things to consider actually. Most of our clients will just say, okay, I just want my water disinfected, but there is definitely some thinking that needs to go into that. And there is a lot of issues that might be the main focus of some customers, but not on others. We can have aging water infrastructure leading to pathogens coming in after our treatment stages. We can have a lack of availability of chemicals. We're seeing that right now on the African continent, where some chemicals, due to freight restrictions or local production breaking down, are becoming scarce. There can be safety issues. Our disinfection strategies can have an influence on the end product or the water end user by byproducts or via other influences. If I'm running a production and my disinfectant is actually causing a slowdown due to a buildup of a byproduct or even my filters clogging up, that can lead to different problems as well. And then there is maintenance time and expertise. Is there enough expertise on the equipment that we're actually using or on the disinfection method that we're using to keep the units going? So if we look at different water treatment and water disinfection strategies, there's a few ways we can go. We have, for instance, UV, ozone, chlorine, chlorine dioxide, and a whole range of other chemicals that can be added. Now, some negatives and positives on these treatment strategies. If we look at the first row, residual. Do I need a residual? Because if I look at, for instance, UV and ozone, which might seem ideal, they're the strongest and medium disinfectant that we have. There's no byproducts. I think it's ideal, but there's also no residual. So after disinfecting with these strategies, there is no residual for the rest of my pipe work. Okay, let's say I'm going then for chlorine dioxide. Hey, I have several days of residual. It's a strong disinfectant, but I am adding a chemical. So there is byproducts, in this case, in the form of chloride, chloride, and chlorate. Okay, let's look at another one, chlorine. It's cheap, the world's most used disinfectant at the moment, and we can get it from different sources, liquid, gas, salt, and electricity. But there is again a whole range of byproducts that might form. And then we have our complete chemical package from peracetic acid to hydrogen peroxide, which can have a wide range of advantages, but also disadvantages. That is where we need to balance it out. What is the end goal of the customer? And that can be very different end goals. We work a lot, for instance, in the baby food industry, where the end goal is to have disinfected water with the minimum amount of byproducts, because those byproducts will go into the end product, baby food. If we have, for instance, a wastewater disinfection or inlet water for wastewater treatment, then the byproducts are of a less concern, but maybe our disinfection power is of a high concern. Flavor influence or color or smell influences can be big ones for instance, the beverage industry. And what do we want to spend? We can put in a full RO and we can make it high purity water, but not every application needs that. So let's have a look at the disinfectant strategies that we have available. If we look at UV and ozone, they both take away the need or the problem of availability of chemicals, because UV just uses electricity, ozone just uses oxygen or air and electricity. Ideal, no more. shipping chemicals around, no more waiting for your chemical supplier. There's no shortage usually of air or electricity, except for when you live in South Africa. Then we have some rolling blackouts every once in a while, but seems ideal. UV doesn't have any safety issues. It doesn't influence the end product because we're not putting any chemicals in the water. It doesn't slow down production, and maintenance is minimal. But there's also no residual. So if I put a UV, for instance, at my inlet water, and I have a pathogen or an infection coming in somewhere from a crack in a pipe, a dirty tap somewhere, then or a backflow from a process, then my UV won't protect for that. Ozone has a residual several minutes. Again, no availability of chemicals. It doesn't influence the end product, and it doesn't have to be a production slowdown, but it only lives for mere minutes. We see this a lot actually in the beverage industry. Why? Bottled water, if we treat that with anything else but ozone or UV, we would get influence on taste and smell. And nobody wants to buy a bottle of water and then have that nice pool chlorine smell if you open the bottle. You're not going to sell a single bottle of water anymore. So again, ozone also, if you put it at the beginning of your pipe work or a long residence time of your water in a tank, you're not going to have that residual protection. That's where we move to our chemical disinfectants. The main advantage of these is they have a residual ranging from several hours to several days. They can resolve issues for aging water infrastructure because they have that residual. Chlorine is good at preventing biofilm. We've just seen several biofilm issues for your RO production. Chlorine dioxide is actually very effective against biofilm and actively removes biofilm in pipework. I've seen shock dosing with biofilm, which literally tore a 1 centimeter thick green slimy layer out of horticulture pipework. But it does have an influence on the end product, or can have. It has influence on the water end user. It shouldn't slow down production, and maintenance time and expertise, if we look at chlorine, is very much dependent on how we add chlorine, because that's the main advantage of chlorine. It comes in many different forms, and we can buy it in many different forms or produce it on site from salt electrolysis. Chlorine gas is pure disinfectant, and it's cheap, it's readily available, but the handling of chlorine gas is very dangerous. You need trained operators, you need a big amount of safety measures. Chlorine dioxide, a little bit less, but there's two precursors that you need, hydrochloric acid and sodium chloride. Are those available? Can I store them? What are my restrictions on these? Pros and cons of chemical addition. And then, of course, we have a wide range of other chemicals. Hydrogen peroxide, for instance, is almost ideal. It dissolves in water and oxygen. We have some residual effect, especially in pipe works, closed-off pipes works. But if we have a look at costs compared to chlorine, for instance, then we can look at a factor 4 or 5 more expensive on your operational side. Peracetic acid requires high concentration and heat. Plus, we have corrosion issues. There's a range of other chemicals available, monochloramines, we have bromine, mixtures for cooling towers, which all come with their own range of problems. Either safety issues, influence on the product, or just not being suitable for that application. If we have a think on what would be the best strategy, then that is always a tricky question. There is no one answer to that. Depending on what the end user requires, and of course what the budget is, we advise the customer at Prominent to go for a strategy. And whether that be making chlorine on site from salt electrolysis, whether it be implementing an ozone generator because he cannot afford himself to have influence on the taste of his product, whether it be chlorine dioxide because he found that most of his bacteria or most of his infections are coming from his pipe work. They have dead ends somewhere, they have listerosis, legionella, um, all can be problems from biofilm. And you're not going to clean a kilometer of pipework in your factory. So that's where we recommend chlorine dioxide, for instance. You want cheap and you want bulk. Chlorine gas can be the ideal strategy for that, all depending on availability. At the moment, we're seeing some problems on the African continent with chlorine supply as well. So that's where our customers are now looking into different strategies for treatment. This is a very short introduction on disinfection strategies. If you want to have a specific application, please drop it in the Q&A. If you have a issue with your current disinfection methods, for instance, feel free to contact me, and then we can discuss that in more detail.